Hello, welcome to my channel. For this video, I want to discuss about work, energy, and power from IGCSE Physics past paper. Okay, for this question, this figure shows a forklift truck lifting a box, and then the electric motor that drives the lifting mechanism is powered by batteries. State the form of the energy stored in the batteries. So the energy stored in batteries is chemical energy. And then for B, the question is asking about the gravitational potential energy. So for GPE, the formula is mass times gravity times height. So we just insert the mass. So the mass at here is 32. So 32, and then the gravity 10. And then the height means at here is the distance because they write vertical distance. So this one is the height, 2.5. So this one's answer is 800 joule. Okay. And then for next one, the efficiency of the lifting mechanism is 0.65 or 65%, and then the question is calculate the input power to the lifting mechanism. So from here, we can use from II. So for, sorry, not from II, but from I. So for this one is the energy output. Okay, so this one for the energy output. And then we want to find the power input. So we have to find the energy input first before we want to find the power input. Okay. So how do we find the energy input? We use the efficiency formula. So efficiency equals to energy output over energy input times 100%. Okay. Actually, efficiency can use formula as power output over power input, but from here, we don't know the power output, so we use this formula, okay, to find the energy input. So the efficiency is 65%, and the energy output just now, the I answer is 800, and then energy input we want to find it, and then times 100%. So this one we cross it, so energy input equals to 800 times 100 over 65. So this one, the answer is 1230.77 joule. Okay, and now we want to find the power. So power, the formula is energy over time. So power input is energy input over time. So the energy, as we refine it, 1230 over 0.77 over the time. Just now the time is 5.4. Yes, the time is 5.4 seconds. So this one, the answer is 227.92 watt. Okay, so the unit of power is watt. So 227.92 watt. Okay. Then for next one, we want to find the kinetic energy. So we use the formula of kinetic energy as half mv squared. So half times the mass. So we see the mass at here is, so this one is figure 2.1, and then a small ship of mass is 1.2 times 10 to the power 6. So the mass is 1.2 times 10 to the power 6, and then times the speed, and then slowly sideways at 0.04 meter per second. So this one is the velocity of the speed. Okay, so we insert it. So this one is 0.04 square. So this one is the answer is 960 joule. Okay. Then, sorry, and then next one for B. The ship is in contact with the pillars for 0.3 seconds as it comes to rest. Calculate the average force exerted on the side of the ship. So you want to find the force. So from that question, from this question, we already know the mass. We already know the speed. You want to find the force. So force is mass times acceleration. So mass, we already know it. Just now is 1.6. Sorry, 1.2. Just now is 1.2 times 10 to the power in 6. And then, but we don't know the acceleration, but we can find acceleration from speed over time. So acceleration is velocity or speed over time. So the velocity just now is 0.04. So 0.04 over the time is 0.3. Okay, so this one is 4/30. So we insert the acceleration is 4/30. Okay, this one the unit is meter over second square. And then this one the answer is 1.6 times 10 to the power in 5 Newton. And then assume that the kinetic energy calculated in A is used to do work moving the pillars and then calculate the distance. So this one means that the KE equals to the work done. So we can write kinetic energy equals to the work done. So kinetic energy that just now we find it from number A, the answer is 960. So we write it 960 and the work done, the formula is force times distance. So F times the distance, okay? So 960, the force is just this one, 1.6. So 1.6 times 10 to the power in 5, and then times the distance that we want to find it. So distance equals to 960 over 1.6 times 10 to the power in 5. So become 6 times 10 to the power negative 3 meter. Okay. And then for next question, this one they asked to find the gravitational potential energy and the force. So we want to find the GPE first. Okay, we want to find the GPE. So GPE, the formula is mass times gravity times height. Okay, from here the mass is 40, and then the gravity is 10, and the height is 1.5. Okay, so this one is become 600. And then next one, we want to find the force. So this one, how do we find the force? So this one is, for this one is the GPE equals to the work done. So usually work done is equals to the energy. So work done is equals to energy. Okay. So we can write it work done equals to the GPE. Why we use the work done? Because our work done formula is force times distance. From here we already know the distance. The distance is 8 meter. Okay, the length of the ram is 8. So the distance is 8. So we write force times distance equals to 600. So force times the distance is 8. So force equals to 600 over 8 is 75. So 75 Newton. So the answer is C. Okay. And then for the next one, a box of mass is 8 kilogram, and then they say that gains 100 joule of potential energy. And then the box falls off the shelf. And then at what speed does the box hit the ground? So we want to find the speed. So means that this one Ke. So this one, the kinetic energy equals to the gravitational potential energy. So you can write Ke equals to half mv square. So the kinetic energy is 100 joules. So 100 equals to half. The mass is 8, and then we want to find it. So this one become 104 v square. So v square equals to 25. So v equals to 5. So the answer is B. Okay, and then for this one, 13. They say that the car has a kinetic energy is 1.6 megajoule and then accelerate for 20 seconds, and then the kinetic energy become 2.5 megajoule, and I want to find the acceleration. We want to find the average power developed by the car engine for this acceleration. So we want to find the power. So power, just now the formula is energy over time. So energy is equals to the, so energy, we write energy over time. So power, it can be energy over time or work done over time. Okay. So but right here they give you the kinetic energy, so we use energy over time. So because this one is have increases, so we want to find the changing of the kinetic energy. So 2.5 times 10 to the power 6 because mega minus 1.6 times 10 to the power 6 over the time is 20. So this one become 0.9 times 10 to the power 6 over 20. So this one, the answer is 45,000. So this one we change into the kilo, so 45 kilowatt. Okay. So the answer is C. Okay, for this video until here, thank you for watching. Bye.